everyone, welcome to Risk Roundup. Computers perform computations, and since software powers the computer that makes anything, any machine, digital or analog, embedded with computers to run on its own, it raises a fundamental question. Are machines conscious? Are machines aware of its surroundings? Now, the answers to these questions depend entirely on perhaps how we understand consciousness in machines. Now, since the term machine consciousness is already caught in an endless explosion of meaning and comparisons, should we try to understand machine consciousness in terms of human consciousness? Or, in a way, it would make sense for machines to follow human commands? Or should we just use a different term for machines? To discuss this further, I'm delighted to welcome John Kontos to Risk Roundup. John is a professor at Department of Science of Cognition and Thinking at National University of Athens. He is the author of the paper Machine Consciousness and Question Answering, published in Skyria Journal of Computer Science and Technology. He is based in Greece. Welcome, Professor Kontos. We are honored to have you on Risk Roundup.
Thank you.
Wonderful, Professor. So it seems there is no central definition or agreement on what machine consciousness is. How should we define consciousness in machine? How should we understand and compare machine consciousness with human consciousness? Or how do you see the concept of machine consciousness relate to human consciousness?
Well, if you have in mind a clear definition of what a machine is, then it's very clear what is possible to define as machine consciousness. You don't have many choices. A machine is just a device that goes through a number of states depending on its input, which comes from the environment. Therefore, it has a history of states that it goes through. And that's all it knows about itself. Unless you ask about what it sees, what it hears, what is the environment. But if we're talking about the internal operation of the machine, the only thing that it can know nothing else, is its own state. Therefore, if you say it is conscious machine, it means it knows at any moment which states it has gone through since you put it on and it started working. That's all the knowledge a machine has of itself, nothing else. It's quite different when you talk about human consciousness, of course, which is very complex and we don't know very much about it.
Yes, very true.
And I'm not qualified to talk about human consciousness because I'm not a psychologist.
Yeah, we don't, and that's the question. Why are we trying to define consciousness of machine in terms of consciousness of humans? We don't need to do that. We just need to stick to the machines, right? There is no need to compare it with human consciousness, but that's where a lot of confusion happens. And it seems that you just said that, they just need to know about their state. Now, it seems Richard Morin determines that the two aspects of consciousness seems important, like perception of self in time and complexity of self-representation. And so if we are looking at all this self-awareness and understanding of the self in time for the computers or machines, how do we measure consciousness in machines? Is there a way to know?
Well, I think that it's in parallel with what we can do with humans too. The only way you can check a human that is conscious is by talking to her or him, asking questions and getting answers and evaluating these answers if they denote that some consciousness takes place. You ask a person what day it is today, what did you do yesterday, are you feeling well? These kinds of common sense questions. Same way you can ask a machine some questions. For instance, the simplest question is, how did you arrive at the present state? It gives you a long list of previous states. You can be more specific and say, how did you arrive at state A, what was the previous state, for instance? These kinds of simple questions, if they can be answered, it's a report, as we say. It's reporting consciousness. It's a report method of checking.
Yes.
And we'll have no other way. Since we have no instruments to measure consciousness, the only way is by talking to it.
Yes.
Either to a machine or to a person.
Yes, yes. So which are different mechanisms by which you insert that consciousness or even that understanding or to manifest in machines? What needs to be done to make a machine self-aware or aware of its surroundings or aware of its internal surroundings? How do you manifest all that in machines?
Well, I don't have already I think I have it somewhere. I have the block diagram in my paper with the, I don't know if we can show this. Perhaps you can amend it after our discussion.
Okay.
There's a block diagram
Okay.
giving the parts of our system, at least, that constitute the whole construction, which is a program or computer system. Computer system is a computer plus a program. Neither a program alone, because program alone cannot exist, must be executed in a computer. Plus a computer makes a computer system. That is something that works, that gives a result. So you can see from my paper at least how the architecture of our own system,
Okay.
which in simple terms, it's able to follow the logical steps followed for giving an answer, which may not be a straight answer. It may be an answer resulting from a logical combination of known facts.
Okay.
And there's a basic method of combination, which is the middle laws. So that is, if A, for instance, causes B and B causes C, then you know that A may cause C. That's a very simple thought. Goes back to Aristotle with his syllogism. And it's a very simple way of combining known facts.
Yes.
And I mention causality because it's one of the basic elements of human knowledge. To know how events or systems cause changes one to another. I'm sure that I'm not following the text, but
No,
you
no,
can.
no, that's completely fine. That's what we want, a discussion, right? So we don't need to follow that. So as you describe, I mean, what conditions any machine, any computer, irrespective of whether it's a laptop computer or a desktop or smartphone or iPad, what conditions or even Internet of Things, what does it need to meet?
For any given computer system, the computer itself, the hardware, is material.
Yes.
What we all use is just an adder, nothing more. The
Right.
basic unit of a computer is an adder. And some ways of doing a conditional change of flow in the program. That's the basic elements. That's all you have in electronic form, basically. The others are auxiliary, just how you connect to a printer, how you connect to the internet, and these are auxiliary program facilities. So the hardware doesn't know anything about what you're doing with it. What you do is you build on a hierarchy of software tools that give you the possibility to program in an easier language than if you programmed in machine language. Machine language is very close to the hardware and very difficult to use. I have done some machine language programming, which is 0101s. You call it's very cryptic,
Yes.
because we built a computer here, if you don't know, in Athens in 1970. And it was a microprogrammed computer, so we had to program in very low machine language. And then you have the assembly language, which is a little easier than machine language. And on assembly languages, you build the languages that a programmer uses, which is more friendly.
Yes.
Now, the easier, to my mind, languages, programming languages to use are the so-called declarative languages, non-procedural. And this is Prolog, one of them. And so in AI, because mainly we deal with syllogisms and reasoning, machine reasoning, and so on, and the reasoning is inbuilt in Prolog. You don't have to program it. It's a very good tool to use Prolog for various applications.
Good. Glad to know that. So this, since connected machines has some sort of self-awareness, it seems, because both external as well as internal for quite some time. So can we say that today machines are more self-aware than even humans? Because if you think about it, I mean, if we try to record events, we don't remember everything. Our processing power, we don't remember that. But
that's correct. Whatever you store in the machine, it will be there forever.
Yes. Yes.
In a human mind, it may not. You forget things. But of course, the human mind has other capabilities, which we cannot mimic all of them.
Right.
And as you saw in the questions further down, one of the basic differences is creativity.
Yes.
Which we haven't achieved yet with machines, and I don't know if can achieve it ever,
but you're working on it, right? You are working on artificial.
I'm trying to. I'm trying to find not to be in the same situation as with consciousness, where I found a definition after I have labored for a number of years. To start from the definition now, and one thing that bothers me is that whether creativity is an attribute or a relationship. And I'm inclined to believe that it is a relationship, which means that I produce something which is creative with respect to some who accepts it, who receives it. If it's new to the receiver, he sees it as creative.
Yes.
It's more logical to see it as a relationship between a creator and a consumer.
Yes, there must be some interconnectivity, because if you look at humans, not all humans are creative. So it must be some sort of interconnected interdependency in the way everything is structured in machine.
As a social phenomenon.
Yes.
It's more of a social phenomenon. So I doubt it if there can be an absolute definition that A is creative and B is not. Even when a computer just makes some mathematical calculations, produce some numbers which were not known before for the program that does the calculation. But if the result of this calculation, somebody sees it and says, but this is known, and it's not original, then creativity evaporates.
Yes, very true. And I mean, we will need to put more effort into understanding machine creativity, or whether we'll be able to create machines that would have creativity is very important in the coming years, because as we explore the space, and as we go on other planets and we try to get a lot of answers, we would need machines to be creative. So I hope that your efforts in this direction are successful, and you are able to not just the definition, but you are able to understand the creativity, what it would require to make machines more creative, so that it would help humans into our exploration.
Particularly, it's very important for innovation, which is necessary for the advancement of our technological civilization. So we have to look at what are the gaps in our knowledge of devices, what is missing for the human good, of course.
Yes.
And it's maybe for an elderly man and a mechanical helper, which will be able to take care of him. Now, this could be something new if we do it, if you.
Yes, absolutely. So how would you go about that? How would you know what is missing? What would you look for in a machine?
Well, this is a social problem. I have mentioned it in my written text, and you make me think now, think ab novo. Well, it depends on the sector. If it's medical sector, if it's chemistry, if it is everyday device that does something. Let's talk about drugs, for instance.
Mhm.
This is one of the areas where we have some practical results. Why do I hear this? Something wrong?
No, it's fine. Maybe it's one of your notifications, something there must
And some advertisement.
Yeah, it's fine.
Never mind. You don't see that.
No.
I always said, no, okay.
Yeah.
Now, as far as drug invention is concerned, so far, before creativity or mechanical invention came in play, you had to try laboriously in the laboratory all possible combinations of some molecules to have an effect for curing something. Now we have a new situation where we can make experiments in silico, it's called. That is, you can use your chemistry knowledge to predict the effect of some chemical compound. And then when you find the one that is near the work you want the new drug to do, you almost have an invention, but then the human mind must come in and do the verification experiments, first in vitro, as it's called, in the lab, and then in vivo in clinical studies. So the first part of the explorative part now can be helped by programs that have an extensive knowledge of chemistry, of organic chemistry, of course.
Yes. No, I hear you on that. Now,
I'm
I
sorry, it's a little dark.
It's completely fine. So, I mean, talking further a little bit more than creativity, in one of the articles, Artificial Consciousness, Utopia or Real Possibility, Giorgio Batasso says that despite our current technology's ability to simulate autonomy, working in a fully automated mode, the computers, that means machines, cannot exhibit creativity, emotions, or free will. So he says that a computer, like a washing machine, is a slave operated by its components. Now, if that is the case, then as the machines become autonomous, and if they don't have free will, if they don't have creativity, if they don't have emotions, then how will they decide and define? Define and decide what they should do. I mean, it's an autonomous car. If a human comes in front of it, whether it should stop or whether it should, just ride over it, or whether it's an autonomous weapon, then, what should they do? Should they, throw a drone, throw a missile on a human population? Or how would it take decisions if they don't have emotions or free will on its own?
Well, the utility of the result is judged by humans, of course. The machine cannot judge the utility of an invention or a new idea. It just has the ability to examine a large number of combinations until it hits the one that does partially, at least, the job we want done. Now, if you want to imagine the system, a computer, I don't like the word machine. We must talk about a computer system.
Yes, let's use the word computer system.
That's a computer and a program.
Yeah.
Well, a program is a finite piece of text. You've written a set of instructions, has a given length, therefore it has its limitations, always. It's not an infinite program that can do anything. And usually it is focused to a given application area. And it's very difficult to transfer technology so advanced as invention from one area to another area. You can, for instance, transfer the techniques you use for drugs to the finding of a new constellation in the sky. I give you the two extremes because there have been efforts to use these techniques in many scientific fields. And I restrict this into the scientific fields where the results are more measurable. Of course, a large number of people that go to these conferences, because there's a series of conferences on computational creativity, are interested in music, for instance.
Yes.
Which is, it's a little, I don't trust it very much because you can easily make a new sound and then the audience will think that this is an original piece of music. How nice. But what is the utility? I mean, it's not very serious to my mind. Serious will be if you really, the program helps you to arrive at the solution of a real problem with social value, like a medical problem, a transport problem, an assisting problem to a human that needs some help because of his inabilities, so on. But music, it's easy. You see, it's easy to start an algorithm that will synthesize a tune that was never heard. And it's no problem with that. Usually, to make it more, familiar, they use some prototypes like Mozart, Bach, and so on, and try to construct music which is similar to their works. But I think it's playing. This kind of activity, it's kind of playing, like solving a crossword or something, with no practical value.
Yes. I'm sure you must have heard that the algorithm that AI Now group that they created, it writes just like humans. So they are not going to release it to the public. So that means the computer systems have developed a capability by which they write just like humans. So they, perhaps have that creative power, that the language power, or ability to think just like the computer system has developed ability to think just like human system. So what are your thoughts on that? What kind of computation?
You must be very careful in using the word like. Like at what level?
Yes.
If it's at the behavioral level, then there can be likeness. You can have the same results given a problem solved. But if you go inside the operation of the software system and the brain, then you're lost. There's no likeness at all. Or we don't know of any likeness.
Yes.
An example of misguided likeness is what is now called deep learning. You've heard a lot about it, which is buzzword. Well, deep learning is the result of the operation of a network of what are called artificial neurons, we have very, very little relationship with real neurons. Very, very little.
Yes.
That's a very basic difference. Uh, Real neurons communicate with pulse modulation. That is, they exchange trains of pulses of different frequencies. And this is not used in artificial neurons. You have just a logical combination of the output of one level, which then is weighted using a vector of numbers. The outputs of one level are multiplied by different weights, and if the threshold is overcome, then you get some output. But it's very little relationship to the real neurons. And it's only the communication part. You go into the processing part, we know very little. As I've mentioned in the notes you have, we don't know how we count.
That is the challenge, right? We don't know how it happens. And
We don't know how it happens.
that is
I challenge a neurologist to tell me how does the brain count? Where does it put the temporary knowledge of a number that it is, how it makes the increment to the next number? Is it an addition operation? Is it a lookup? Nobody knows. Because we don't have the tools. You see, the most, the highest resolution that I've seen is MEG, magnetic electroencephalogram, or something like this, MEG. The only thing they've managed to see experimentally is that when you see a word and then read it, they can find about 4 areas of the brain that are excited consequently until you speak. You see, first you have at the back of your head the optical sense, what you see. Then which is a picture, when you start, then it goes to the language center, so that you recognize the word. Then it takes some time there to understand it somehow. Then if you understand the word, it's a known word. Then it goes to the motor part of your brain, that you speak it. And that's all. But this 4 movement from one area to another is a very coarse description of what happens.
yes.
Even for the simple reading of one word. Now, if you go to counting, we know nothing, almost like where is it stored? Where I am now. I am in 125.
Right.
And then if you want to more complex, say add by 2 and add 3. How does it happen? So we have counters and adders in the computers, but there's no sense in saying that they operate like a brain at the architecture level.
Yes, but at the same time,
It's only the behavior.
yes, but at the same time, I'm sure you're aware of so many different initiatives that are trying to, the neuromorphic computing and neuromorphic chips, they are trying to create a silicon brain that operates just like a human brain. So
To my mind, it is misguided because we don't have enough knowledge. You see, before I'm getting involved into AI, I worked for a number of years in simulation. And what they're trying to do is a simulation. In order to do a good simulation, you must have a lot of knowledge about the system to be simulated. With this little knowledge we have about the brain,
yes,
it's almost impossible to simulate.
absolutely. I mean, you are right about it. We don't know much about human brain at all, and we are trying to create a silicon brain that is based on a human brain. So yes, there are a lot of challenges, but again, that brings back to the same question: do we need to create a silicon brain that operates like a human brain? Why?
No.
We don't need to do that.
We don't need that. Because we have our own information processing technology, we can advance this to overcome the difficulties we have now. And well, there are various methods. Either you do it by using past experience in a brute form. That's what neural networks do, artificial. And to my mind, and I've written a short, how do you call it? A short paper in a conference, but I didn't have time to expand it. That to my mind, all these efforts are just, in a way, indexing the known examples. They try to somehow connect them in groups, and so that when a new example arrives, the only thing you can do is to define a similarity measure and decide in which group from the known examples it can be classified. So there's no reasoning really involved. A lot of it is table lookup somehow. You have a lot of examples. And this is also another basic difference with human brain. The human brain learns with very few examples. If you get burned once, you don't need to get burned thousands of times until you learn that you must not go near a flame. But systems like the ones that some of the companies, I don't want to mention the names, advertise, they need thousands of examples in order to be able to classify as something safe or dangerous, for instance. But the human once gets burned, and he knows that flame, she knows that the flame is dangerous. Don't go near it.
Right. Now, in your paper, you describe that consciousness can be implemented in computer systems by using either finite state automata or production systems. What behavior you think can be characterized as exhibiting consciousness, and how do you generate that?
Well, first of all, I must say that finite state machines and a set of rules, since they are finite and not an infinite set of rules, they are equivalent. There have been mathematical theorems in the past that prove this equivalence. So it's a matter of technique. What is easier to you, to the programmer? And a programmer is accustomed to work with rules, since he constructs programs. And the program is a set of instructions. It doesn't consist of transitions of states. It doesn't say now I go from state 1, state 2, and state 2. It says do that, which means change some attributes of the present state. In some part of your memory, replace the present content with a new content, which is the result of the application of a rule that gives a result. You get some data, and you follow the rule and produce an output. Is that clear? It's very difficult sometimes to make it understandable to somebody who hasn't programmed. Have you programmed?
Me, I don't do programming.
You don't do programming.
No, I don't do that.
If you're interested in the field, it's very easy to learn a little.
Yeah, but there are a lot of programmers. I am doing different things.
Because a lot of misconceptions get diluted if you have a little of experience in programming.
Yes, I did a little bit, long time back, but I don't do that anymore. I just do analysis of all this technology.
Well, so because it's we work with Prolog. Prolog is a program consists of a set of rules.
Okay.
That's why I mentioned the alternative.
Yes.
In one of the papers, I don't know if it's in this latest one, I have constructed an alternative way using Prolog to materialize a state machine. If somebody is able to program which means you draw a diagram with the nodes and the states and the transition from state to state, you define on which input they go from one state to another. Then we have a Prolog program that can follow these rules, which are not the usual logical rules, they are rules of change state. They're triples, as we call them. And just three pieces of information. Present state, input, next state. So the automaton is nothing but a list of these triples. And then you have what we call an interpreter, who starts from the start state, sees what is the input, and calculates the next state. Then, knowing the next state, looks again at the input and finds what is the next state. And it's all done automatically, but it's not very easy to program in this way, not the usual way.
Right. So where do you see its application? Where do you see?
There is a correspondence between the two. We can look the same things both ways.
I see. So what would be the output of these software system operations, and what will be the nature of operation, as you move forward on that?
Well, the output, the most useful output usually is an explanation. That's what we seek for. And if you are aware of the 1916 report, USA government report on the future of AI, and that was an Obama group that was established for some time, and they produced a report, which is written in simple terms. I mean, it doesn't need many technical knowledge, much technical knowledge to understand. There is a critique of these artificial neural network systems, that they are unable to produce explanations, and therefore convince their users of the correctness of their operation. And this, particularly for military devices, is very important.
Right.
And since then, they talk about what is called XAI, explainable AI. And since 1917 onwards, DARPA is investing on projects to produce systems that have XAI.
I see.
I don't know if it's too much for this discussion.
No. Right. No,
have a look at this report, and
I will.
Some other time we can discuss it.
Sure. No, I will definitely look at that.
It's a government document.
Yes.
It's the first time that there was a government in the world in 1960 was the first government strategy on AI. And then some other followed. There's a Chinese document, there's a Russian document, but it came out after. USA was first.
Yes, no, that's what we are researching right now, and evaluating who is working on what and what would be the security risk emerging from that. So that's what I will definitely evaluate what you just recommended. So now it seems that you have implemented this software system that generate automatically user-friendly explanation of the answer. So when you ask a question, it gives you a answer in that you can understand. So what process follows the user's question? If I ask a question, what follows in the computer system to activate the behavior that resembles the conscious agent and
it's simple. No, it's simple. There are two possibilities. Either the answer is stored and your question matches some pre-stored answer, and then the only explanation you will get is, I found this in my memory, and I give you the answer. A second, little more complicated, is that if the program needs to do some calculations, it will give you the steps of the calculation that results to the what you've asked for, the power of 2,
Yes.
2 to the power of 3. Then will tell you I multiplied 3 times 2 by 2, 2 by 2, 2 by 2, and this is an explanation of how I arrived at the answer, which is 8. A non-conscious system will give you just the answer. What is 2 to the 3? 8. But you don't know how it computed it. If it explains how it was computed, then you have an explanation. I give simple examples for trivial, but in order to make it easier to understand. In a more complicated situation that we have worked with is looking into papers in biomedicine, where you find facts of interaction between proteins, and you're trying to find out if there is a chain of interactions that will give you the information that protein A interacts with protein B, and then B interacts with protein C, and so on until A protein causes some change to protein Z, which is a few stages forward. This knowledge is stored in papers because individual researchers look for one causal relation because of the cost and the time. Now, if you collect this literature and try to analyze it as altogether, then perhaps you can find chains of interaction between the proteins, for instance,
I see. I see. So,
or other molecules.
right, right. Now, if, as you know, in the neural networks and these deep learning, as the systems, become more complex, and as the program, complexity goes higher, there is no way the programmer will know how it is doing what. We just don't know how the autonomous systems will operate or how it will develop, or we just don't know how the neural networks will understand what and how it will come to the decisions and understanding. So it seems that we need a new kind of software engineering, because the current ones where we don't have any control, once these computer systems become
Oh yes, and it can be dangerous, and that's what. And if you read this report, you'll see the people are worrying about. And
yes.
these people are not technical people who want to advertise their expertise. They're representatives from various agencies, government agencies, who are seriously concerned about the operation of such systems.
Yes.
And that's why they insist on explainable AI.
Yes.
And it's only 2 years old, this effort. Although there were older efforts, which I was surprised, which I was aware of. The first one part of what we called in the past expert systems. Some of them had the ability of explanation.
Yes.
Somehow the USA has forgotten them. And it's their own work.
Yes.
If you see this report, it's funny they don't mention any of these older researchers who had given an explanation facilities to expert systems. Now, the term expert system is not very fashionable, perhaps, and that's why they were not familiar with this older literature.
Yes. Yes, no, I hear you on that, because see, we do need to have some sort of control over these computer systems. We don't want to create computer systems where we just have no control, and tomorrow the future of humanity is at risk. So I think there is a greater need for developing a different, or having a different approach
Oh, yes. Yes.
as we move forward.
So the problem is older. It's not that it didn't appear now with the neural networks. If you look at the big operating systems, for instance, like Windows that you use every day, why do you get new editions? Most of the time because a bug was found. Because when the system was programmed, there was no deep interaction
Yes.
of the programmer with the system to be able to predict the bugs, to find the bugs. So whenever they found a few bugs, they produced a new edition.
No, I haven't. I haven't.
Did you get that?
No.
If you look at Windows, they have various editions.
Okay.
1, 2, 3, 10, now we're at 11.
Okay.
Some of the differences are new capabilities, but most of the time it's fixing bugs, errors of the original program,
Right.
which come on the surface after use, because the programmer of this is a huge program. An operating system is a huge program.
Yes, they are. Yes. Yes.
And usually programmed by a group
Right.
with very little communication. I mean, it's broken down into many simpler programs, and the programming, each individual programmer works in part of it, and then they're put together with somehow obsolete technology. That is, while the system is being built from its components, there is no record of how they interact. There are no experiments done during the building of the complex system. So to my mind, the new technology, new software technology, which I don't have now full knowledge of what's going on in companies that work in software engineering, you have to start from basic operations, and in your way to solve the task that you have in mind, you must be sure that the previous phase is correct.
Yes. Yes.
Otherwise, you're using components to build up a more complex component, and if you don't know that they're bug-free, they're bug error-free, the component you use, there's a danger that the combination of them will show an error during operation, which will be mainly non-understandable.
Yes, and not only that, we will lose control over it, right? And that
Yes.
is the concern.
It will be operating in ways that can be dangerous, unsafe.
Yes, very true, very true. So that is the cause of great concern, and that's why we need more transparent and more ways that we can control these computer systems in the coming years. So having said that, what would you like to tell our global viewers and listeners, and especially those young minds who are so interested in exploring machine consciousness? And also, I think you have written many books. If you could, share some details about those books.
Oh, not many. Well, the one in English, the only one. I'm sorry. This is, you cannot read it, of course, but.
I can read Artificial Intelligence. Oh, great.
Yes.
Conscious Eye.
Yes. It has a funny story. It started always as science starts with art. My friend he's an artist, the co-author, and she has written a book on consciousness in 1986. Because she was wondering, what does cubism mean?
Cubism.
What is cubism? Being an artist, she was interested in cubism. And her theory was that it's a turn to consciousness, not what the artist sees, but how it sees. So you can see the idea of combining different views of an object in cubism. If you see a cubist picture, cubist painting, you see that, for instance, a face will have a profile of a nose, not nose like this, but the nose turned 90 degrees. Actually, on the particular subject of the nose, we have written a paper too with Polly to explain, to talk about anomaly detection. You see it as anomalous when you see it. When you see a Picasso face, it looks anomalous because it's not what you normally see.
Yes.
But he was trying to combine different views of a face.
I see.
So she proposed then that it was a time to consciousness.
Yes.
That you try to think how you see.
Yes.
And make a picture that somehow represents this process of seeing. Of course, in 1905 or something, how we see, how we saw and how we still see, nobody knew. I mean, neurology was, but it was the imagination of the artist to try to play with this. And then I took her book, was in Greek, and asked her to translate it in English, because I knew that the book that I wanted to write would have almost zero audience in Greece. Even now, in the English-speaking world, it's almost unknown. It is in Amazon, and very few people know about it. But what I try to do is to use her as a Pythia. You know what is a Pythia? Pythia was the...
No, yes, absolutely. This looks like an important book, so I hope that our global viewers and listeners get an opportunity to go on Amazon and purchase this book and read about it. So I would recommend that.
So I took statements which were simple-minded, but were thinking about technology, were referring to some aspect of AI or consciousness at that so early. And I put this as a motto in about 10 chapters. And I tried to review the scientific literature since then, since 1998. And I hope I have come to 2015, when the book was published, with as new knowledge as possible. And this is when I got interested in creativity. And there are 5 chapters in this book reviewing various aspects of creativity. Already consciousness was getting out, it was becoming obsolete for me, having it solved in my mind how a machine can be, computer system can exhibit consciousness. I said, well, the problem is solved, so let's go to something more difficult.
Yes, definitely. No, I look forward to reading that, and hopefully, next time we talk, we can talk about that book and discuss your efforts on creativity and how, what kind of success you are getting. So thank you so much, Professor Kontos, for participating in Risk Roundup today.
Thank you. You can publish the official answers, if you like, together with the interview, because we didn't cover all the answers. It's up to you. It's up to you.
Okay. We appreciate your thoughtful insight on machine consciousness and hope to understand your efforts on artificial creativity in the near future. So our global viewers and listeners will benefit tremendously from the understanding you provided on computer systems consciousness. So even if a single individual or entity is able to benefit from the discussion we had today, this Risk Roundup dialogue has been of service, and we thank you for that.
Thank you very much.
Wonderful.
Happy to meet you.
Risk
All the best. All the best.
Likewise, Risk Roundup, a global initiative launched by Risk Group, is a security risk reporting for risk emerging from existing and emerging technologies, technology convergence and transformation happening across cyberspace, geospace, and space. We at Risk Group believe that risk management, security, and peace, they walk together hand in hand. Though security is related to management of threats and peace to the management of conflict, risk management is related to management of security vulnerabilities as well as management of conflict. And it is not possible to conceive any one of the three without the existence of the other two. All three concepts feed into each other. We believe that the security we build for ourselves is precarious and uncertain until it is secure for everyone across nations. Tradition becomes our security, so if we build a culture of managing risk effectively, it will lead us to security, and security will lead us to peace. Let's manage the existing and emerging risks together. For more information on the Risk Roundups, to watch the Risk Roundup webcast or listen to the Risk Roundup podcast, please go to riskgroupllc.com and do not forget to subscribe and share. Until next time, I'm Keshri, host of Risk Roundup, signing off. See you next time. Thank you.